Hello and welcome to another video. In this video, we will be talking the whole path of learning and mastering the front end. I will cover everything you need to learn to call yourself a master in front end. So, it will be a very long video as there are tons of frameworks and topics to cover. Get yourself a cup of tea, sit back, relax, and let's jump right in. First, HTML. What is HTML? HTML stands for Hypertext Markup Language. It is the standard markup language for creating web pages. It describes the structure of a web page. It consists of a series of elements. The elements tell the browser how to display the content. The elements label pieces of content such as this is a heading, this is a paragraph, this is a link, etc. So, what do you need to know? You need to understand how to write semantic HTML, learn how to write and implement the most common elements. Once you are done with the basics, you can proceed to the next level. Next, CSS. CSS is the language we use to style an HTML document.CSS describes how HTML elements should be displayed. You will need to learn the basics such as floats, positioning, display, box model, CSS Grid, and of course Flexbox. Once you have mastered them, you can start to make layouts easily. You also need to learn media queries, such as by using ID and class. You could also learn up some pseudo-elements and transitions, which can make your web page a lot better. Thirdly, JavaScript. JavaScript is the world's most popular programming language. JavaScript is the programming language of the web. JavaScript is easy to learn. You will need to learn the syntax of it, such as how to declare and initialize variables. You need to learn fetching API as well as use the fetch function. This ensures you can create a front end that is interactive with data. And then you need to look up ES6 and modular JavaScript, which is widely used in frameworks such as React. Most importantly, you need to know how loops and conditional code works. Next, NodeJS. NodeJS is an open-source, cross-platform, back-end JavaScript runtime environment that runs on the V8 engine and executes JavaScript code outside a web browser. Node.js comes with NPM. You need to know at least how to install packages for NPM. Another alternative is Yarn. NPM improved a lot, but is still behind Yarn in some features, nothing serious, so just pick one to learn. On to the next topic, CSS Pre-processors. They are namely Sass, Post-CSS, and Less. A CSS preprocessor is a program that lets you generate CSS from the preprocessor's own unique syntax. There are many CSS preprocessors to choose from, however most CSS preprocessors will add some features that don't exist in pure CSS, such as mix-in, nesting selector, inheritance selector, and so on. These features make the CSS structure more readable and easier to maintain. To use a CSS preprocessor, you must install a CSS compiler on your web server, or use the CSS preprocessor to compile on the development environment, and then upload compiled CSS file to the web server. The preprocessors actually make your CSS way better and productive. Post-CSS is not a preprocessor but can be used as one. You better be going with Sass and revisit Post-CSS later. There is still some less in the market, but I won't go for it if I'm starting in 2019. Moving on, CSS frameworks. A CSS framework is a library allowing for easier, more standards-compliant web design using the cascading style sheets language. Most of these frameworks contain at least a grid. More functional frameworks also come with more features and additional JavaScript-based functions, but are mostly design-oriented and focused around interactive UI patterns. This detail differentiates CSS frameworks from other JavaScript frameworks. Two notable and widely used examples nowadays are Bootstrap and Tailwind. CSS frameworks offer different modules and tools which include Reset Style Sheet, Grid especially for responsive web design, web typography, set of icons in sprites or icon fonts, styling for tooltips, buttons, elements of forms. Parts of graphical user interfaces like accordion, tabs, slideshow or modal windows, lightbox. Equalizer to create equal height content and often use CSS helper classes, left, hide. Now, we will look at CSS architecture. With modern front-end frameworks, there is more push towards CSS in JavaScript methodology. However, you should at least learn BEM, which stands for block, element, and modifier. BEM, block, element, modifier, is a component-based approach to web development. The idea behind it is to divide the user interface into independent blocks. This makes interface development easy and fast even with a complex UI, and it allows reuse of existing code without copying and pasting. Number 7. Pick a framework. Most popular frameworks include React and Angular. Before you start this, you should have a good understanding of what single-page applications are and how they work and what are the positive and negative aspects of single-page applications. I will talk about React first as it is the most popular one nowadays. React is a free and open-source front-end JavaScript library for building user interfaces based on UI components. It is maintained by Meta and a community of individual developers and companies. The fundamental topics you need to learn include functional components, props, states, conditional rendering, component lifecycles, basic hooks such as useState and useEffect. There are actually a whole lot more topics that are included in React, so maybe we will talk about the advanced ones in another video. Once you learn the fundamentals, you are actually good to go. Number 8. Testing your app. You can actually fulfill your testing needs with these three, namely, Jest, Enzyme and Cypress. Testing is a line-by-line review of how your code will execute. A suite of tests for an application comprises various bits of code to verify whether an application is executing successfully and without error. Testing also comes in handy when updates are made to code. After updating a piece of code, you can run a test to ensure that the update does not break functionality already in the application. Why test? It's good to understand why we're doing something before doing it. So, why test, and what is its purpose? The first purpose of testing is to prevent regression. Regression is the reappearance of a bug that had previously been fixed. It makes a feature stop functioning as intended after a certain event occurs. Testing ensures the functionality of complex components and modular applications. Testing is required for the effective performance of a software application or product. Testing makes an app more robust and less prone to error. It's a way to verify that your code does what you want it to do and that your app works as intended for your users. There are 3 types of test. First, unit test. In this type of test, individual units or components of the software are tested. A unit might be an individual function, method, procedure, module, or object. A unit test isolates a section of code and verifies its correctness, in order to validate that each unit of the software's code performs as expected. In unit testing, individual procedures or functions are tested to guarantee that they are operating properly, and all components are tested individually. For instance, testing a function or whether a statement or loop in a program is functioning properly would fall under the scope of unit testing. Secondly, component test. Component testing verifies the functionality of an individual part of an application. Tests are performed on each component in isolation from other components. Generally, React applications are made up of several components, so component testing deals with testing these components individually. For example, consider a website that has different web pages with many components. Every component will have its own subcomponents. Testing each module without considering integration with other components is referred to as component testing. Testing like this in React requires more sophisticated tools. So, we would need jest and sometimes more sophisticated tools, like Enzyme. Thirdly, snapshot test. A snapshot test makes sure that the user interface, UI, of a web application does not change unexpectedly. It captures the code of a component at a moment in time, so that we can compare the component in one state with any other possible state it might take. Number 10, Typecheckers. The most renowned right now being TypeScript. TypeScript is a programming language developed and maintained by Microsoft. It is a strict syntactical superset of JavaScript and adds optional static typing to the language. It is designed for the development of large applications and transpiles to JavaScript. You might need to learn more Complyact's syntax, so better be prepared. Number 11, Server-side rendering. Server-side rendering is the ability of an application to contribute by displaying the web page on the server instead of rendering it in the browser. Server-side sends a fully rendered page to the client. The client's JavaScript bundle takes over and allows the single-page application framework to operate. If you are using React.js, the Next.js would be the best choice for you. Next.js is an open-source web development framework built on top of Node.js, enabling React-based web applications functionalities such as server-side rendering and generating static websites. You can check it out their web page, as they have full tutorials to get you prepared. If you are using Angular, then you might need to try out Universal, but Angular is not my cup of tea, so I don't really know about it. Number 12, Mobile applications. I would suggest you to learn either React Native or Flutter. Both have their own downsides and advantages. But by learning any one of them, you are actually good to go. As we can see now, Flutter and React Native have many things in common. First and foremost, they are both open-source frameworks that anyone can use. They both are developed by leading companies. Google created Flutter versus React Native was created by Facebook. To compare basic info about Flutter and React Native, you can check this info by NIX. Flutter is easier to use as it is more resistant to system updates. It means that when iOS or Android update the OS, the app will remain the same. On the contrary, React Native depends on native elements, so when the update is released, some problems may appear in the launch app. Currently, Flutter supports Android 4.1 Plus or iOS 8 Plus, while React Native supports Android 4.1 Plus and iOS 10 Plus. The biggest difference between React Native and Flutter is that Flutter has plugins developed by the Google team, like geolocation and mapping. Unfortunately, React Native app works better with apps with a one-time location and does not require tracking. All in all, Flutter and React Native are great choices to save time and money on mobile app development. What framework to choose will depend on the preferences of the developer and the company. Now that's all of them. What's next? Continue learning. Learning in the flow of work is one of the most powerful levers available to business leaders today. I believe every organization or individual can benefit from this new paradigm. It's an exciting next wave of innovation, which has been a long time coming. Make sure that you are on the crest of it. Thanks for watching, and I hope you stay safe.